angle is with a common endpoint. Okay, so that's really what an angle is, and you can name an angle by its vertex, but we need to know what a vertex is. So a vertex is just we're going to go ahead and put some additional definitions here. So a vertex is really just the endpoint. Okay, and so let's go ahead and draw this out. So you can name it by its vertex. So if I draw a picture, okay, and I name this point here A, that right there, that endpoint is the vertex. So we can name it by its vertex. So in this example, in this picture, we can name this by calling it angle. So I'm going to use a little symbol for angle, angle A. Okay, again, I'm going to use the point, and the point is always capitalized, so there's your angle A. We can also do it by number, and by number, let me draw that one again. So by number, say they could have a 1 here. We can call this angle 1. Okay? Alright. Another thing we need to add here is the name of the side. So here's your endpoint A. Here's your angle 1. The sides themselves, these right here, that's the and let me highlight that so you can see what I'm talking about. These right here, okay, those are called sides. So let's just go ahead and put an additional. So the sides are also they're the two rays. Okay, and then the middle point is the endpoint, which is the vertex. All right, and the last thing we're going to point out here is sometimes when you're naming things, you have to actually use different points. So let's say I draw another one similar to this. Okay, and let's say this is 1 and this is 2 and this is point A. Alright, well, in this situation, okay, I'm going to need additional information because I don't know which one they're talking about. See, if I use angle A here, I don't know if they're talking about angle 1 or angle 2, so I'm going to need a little bit more information, so I'm going to need some points here. So let me go ahead and call this M, T, and H. And it says, so we're going to go ahead and name a ray. So let's look at angle 1 here. If you could see the 1 here, we're going to use 3 letters to indicate this with letters because I can't use angle A. So angle A is not going to work. So what I'm going to do is I'm going to call this particular angle for angle 1. So let's say angle 1. Well, we can also name that as angle MAT. Okay. And what's important here is when you name an angle, okay, the most important thing is that if we're going to use points, the vertex, okay, the vertex is this one in the corner, the A, that has to be in the middle. So this is the vertex, and this has to be in the middle. So if I'm talking about angle 1, MAT, the A is what gives it. It's how I know what I'm talking about. MAT, I'm talking about this angle, MAT. So A, the vertex, always has to be in the middle. Okay. Another example I could use here, if I was to talk about angle 2, I'll just put it here on the side. So angle 2 can be thought of as angle, again, TAH. So angles TAH. And you might be asking, Mr. Castro, can I change this, the letters the other way around? Can I call this angle equal to HAT? You can. You can go this way. You can go clockwise. You can go counterclockwise. You can call it HAT. So HAT. So either way, it works. Just make sure that the most important thing is the A. The A's have to be the vertex. They have to be in the middle, okay, to indicate what angle you're talking about. Okay. All right. Moving on. So here we have M. It has this little M in the front. Okay. So this little M means measurement. So we want to go ahead and just kind of put in the side note here. This means means measure or measurement. So we want to measure angle DOG. So when they have the little M, they want the value. So here's DOG, dog. So DOG and O is the center one. So they're talking about this angle right here. Okay. So DOG measures 52 degrees. So the answer would be 52 degrees. Okay. So M stands for the measure. So they're asking for the value. Now, what if it doesn't have the M? So let's say it just says angle DOG. Well, they're just talking about the angle itself. So it's just saying that they're talking about the angle itself. They're talking about this angle, the DOG. Okay, so it has no value. That's what I'm trying to show you. So when they talk about this by itself, they're talking about just the angle itself, DOG. When they have the M, M means the measure. Okay, moving on. Let's go ahead and look at equal versus congruent. We talked about this last time on 1.2 in segments. So equal has a value. So if we look at this triangle, it says the measurement of angle A. So they're talking about this angle right here. So this angle right here is 70 degrees. Okay, and the measurement of angle BAC. So BCA. That's this one right here. That is 70 degrees. Alright, so that means that these angles are equal because we know that the measurement of angle A is equal to the measurement of angle BCA. And they're both equal to 70. So anytime you actually have a specific value, that's equal. Okay? Now, here we have, on this side over here, on the right side, we have triangle ABC is an isosceles triangle. Well, what do we remember from an isosceles triangle from last time? Well, the sides are the same. So we indicate this by using little dashes to indicate that the angles are congruent. They're the same. So remember, congruent means that they are the same. So if it's an isosceles, the sides are the same, but also the angles. And so how do we indicate that the angles are the same? Well, we use dashes to indicate sides are the same. So we're going to use a curvy little, I don't know what would you say, you know, this little swoosh thing occurring here. So this little line, this little angle that I'm doing, this little swoosh, it indicates that these angles are the same. So by using this here, I'm saying that angle 1 is congruent to angle 2. Okay, and when it comes to sections, we'll use the little dashes here. Okay, all right, moving on. All right, so here we have, what are the measurements of angles LKN, JKL, and JKN? So let's start with the first one. Angles LKN. Okay, so L's KN. So they want us to find the measurement, and then we're going to classify these as either acute, right, obtuse, or straight. So before I start this, let's go ahead and go over what are each of these. Okay, so let's go over what's acute. So here at the bottom, we have acute angle. Well, acute angles are less than 90. Okay, so less than 90 degrees. So that means that it's going to be something small. So something that is very smaller than 90 degrees, that's something what it might look like. All right, a right angle, well, that's pretty much, it equals to 90 degrees. As we go further down the unit, you're going to see that the symbol for 90 degrees is this perpendicular. It's the perpendicular little square here in the corner. That tells me that this is a right angle. So you could say 90, or you could use this little square between the two rays. Okay, obtuse. Obtuse is between 90 and 180 degrees. Okay, so it's more than 90. Okay, so but it's more than 90 and less than 1. And let me write that. It's between 190, 180, but it's less than. It's more than 90 and less than 180. So just to make sure, okay, so 90.1, okay, works. Okay, 179.99, that works. It has to just be less than 180, more than 190. All right, a straight angle. Well, straight angle is 180 degrees. Straight angle is a straight line. So just remember something like this, a straight line. That angle from here to here measures 180 degrees. That's a straight angle. All right, let's go ahead now, go back to the problem. So we're going to find the measurements of LKN. Well, let's look for LKN. So I'm going to go get my highlighter here. And so let's look for L. So here's L. And remember, the letter K is the most important one. So L, K, and N. So there's this first one. All right, so we want to find this particular angle. So if I were to find this angle right here, that's what the one they're talking about. LKN. So what would you classify that? Would that be acute, right, obtuse, or straight? So we know it's not acute. Acute is very small. It's something very small. This is way more than that. So this is more than an acute. This is more than a 90-degree angle. This is going to be an obtuse. So we're going to go ahead and say that angle LKN is going to be an obtuse. Okay? Alright, good. Let's move on. Let's go on to the next one. So the next one is going to be JKL. So let's look for JKL. So J, where's J here? JK. So JK and L. Here's L. Alright, so again, if we classify this angle, they're talking about this one right here. Alright, this angle, we know that is going to fall under the acute angle, so we're just going to go and say angle JKL is acute. Okay, that's going to be less than 90, so it's a small angle. Alright, let's go on to the next one. JKN, so go ahead and erase this so it's not bothering you guys. We can visualize this. So JKN, so J, K, and N. Alright, so there's this one. So JKN. So if you notice, this is going to give us a 90-degree angle. We can indicate that by a square that tells us it's a 90-degree angle. So we're going to go ahead and say that angle JKN. JKN is acute. I'm sorry, not acute. It's going to be a right angle. So let's go ahead and correct that. That's going to be a right angle. Alright, so there's the three. Now, there's only one more missing. Can you guys find an example of a straight angle? Okay, so a straight angle means something that is straight. There's only one answer here. The only one that could work is this angle right here. So if you thought of HKN or NKH, remember the order doesn't matter as long as you show that K is the angle. So I'll go ahead and go backwards. I'll use NKH. So I could say that angle NKH is obtuse. Even though they didn't ask us, we might as well learn this one, okay? So that's a straight angle. So I give you an example of each one. Okay, let's go ahead and move on. Alright, use the diagram to answer the following questions. So we're going to go ahead and look at angles CBJ. So let's look at the diagram first, okay? So notice that it has these little swooshes, these little dashes around on the angles end, showing which ones are the same. So here's the thing. So here you have one little swoosh. It should equal this little swoosh, okay? And then you have these with two swooshes should equal the ones with two swooshes. So that would be that angle. That means that they're the same. And then finally you have these with three swooshes. That should indicate that those three swooshes should be the same. So those angles are going to be the same. So that's how we can distinguish. So we know the ones in yellow, these two angles that have one swoosh, they're the same. The ones in green, those are the same. And then the ones in orange here, those show that they're the same. Okay, so let's go ahead and answer this problem. So we have angle CBJ. So CBJ. So we're going to go ahead and look for B here. CBJ. So here's CBJ. That's this one right here. Well, those two swooshes are going to equal to these two swooshes. So we're going to indicate by showing which ones that could be. Well, it could be any of, you can use these following letters. You can use the B, and we definitely need H, and we're going to need G. So we could use B, H, G, or we could use F, H, G. It doesn't matter which of these two letters. What we do need is the H for the vertex and then the G to end. So we'll just choose one. I'm going to go ahead and use the D. So this is going to equal to angle D. H is our vertex. That's the one right here, and it's going to go towards the ray, towards G. So there's my angle. So angle CBJ is equal to angles DHG, or I could have also said that it equals to angle FHG. You gotta realize in angles there's a lot of ways to write these, okay? And you can also switch the letters around, so there's many ways you can write this. Alright, let's go ahead and move on. Let's look at the next one. So the next one says we're gonna look at FJH. So let's look for F. Here's F, J, and H. So they're talking about this angle right here. FJH. Which angle can we say it's equal to? Well, we're going to say that's going to equal to that one. Again, J is the vertex, and we can use A or B as the first letter. Doesn't matter which one. You can go either way. So I'm just going to go ahead and say BJA. So we're going to say that angle BJA is equal to FGH, and you can also do it the other way. You can say angle AJB would have worked also. Okay. All right. So those two angles are the same. All right. Moving on. All right, we have the following. We have the measurement. Again, this is the measurement, and the measurement, okay, of EF, so EFD, so EFD, that's this one right here. So they're talking about this angle right here, okay, is equal to 75, so we're going to go ahead and put 75 here, 75 degrees. And they want to know then what's the measurement, okay, the measurement of GAB. So we're looking at this 75 to the measurement of GAB. So let's look for GAB. So GAB, so JAB. This is going to get confusing with so many there. So JAB, that's this one right here. So these two in orange, those are two angles we're talking about. Well, if this is 75, you can see the little swoosh. They have one little curve. So those means they are the same. So therefore, we know that this angle is also 75 degrees. So therefore, angle GAB is also equal to 75 degrees. All right, moving on to this one. The measurement of GHF. So again, GHF. So GAF. Let's see here. GHF. They're talking about this angle right here. So I'll go ahead and highlight that. They're talking about that one. GHF. Well, that one's going to equal to 130 degrees. So they're talking about this one being 130. So GHF is 130. Then the measurement of JBC. So we got to look for JBC. All right, here's J, here's B, here's C. They're talking about this one. So you can see with the two little swoosh lines that these angles are the same. So therefore, this angle has to also measure 130 degrees. So the answer is 130 degrees. Okay. All right. Let's move on to the next one. All right. Angle bisector. Okay. So we got to go back to what is bisector. Okay. So we've talked about this before. Bisector means that it's to cut in half. Okay. Cut in half. So an angle bisector is a segment, ray, or line that divides an angle into two congruent angles. So this is very similar to the segment. The segment would be cut off by a point, another line or a ray, and it would cut that in half. Okay, and we end up with the midpoint. The angle bisector is going to cut this angle and cut it in half, so you end up with two equal angles. So let's look at how this would look like. Okay, so I have KE, that's ray KE. You can see that by the symbol. This is my endpoint. Ray KE is the angle bisector of angle K. Well, that's easy to draw. We're going to draw angle K. So let's just draw that, and let's call this K. Okay, so there's our angle K, and it's going to be bisected. Bisected means to be cut in half by this ray KE. So endpoint is the K, and we're just going to indicate, try to cut it halfways, and so this would be point E. So there's my ray KE bisecting, cutting in half this angle of K. So that means that this swoosh, this angle, is going to equal to this angle. We use the little swooshes to indicate, one and one, just to indicate that these two are the same. Alright, so now you know what angle bisector means, just to cut in half. So let's go ahead and now solve some of these problems. So we're given the following. We got AT, okay, ray AT, okay, that would be this one right here, is bisecting. It's going to bisect, is the angle bisector of angle MAH. So MAH is the larger angle here. So that's telling you that this is cutting it in half. So we know that this angle MAT, okay, equals this angle, because it's cut in half, so they're equal in value. So we're going to go ahead and say the following. we're going to go ahead and find x. That's what they're asking for. So given that this is the angle bisector, and the measurement of angle MAT is equal to 60. So we're going to tell you that this angle equals to 60 degrees. Okay, and the measurement of TAH, we already know it's 60 because it's cut in half, but it's also equal to 4x plus 20. Okay, the question is asking is what is x? So it's not asking for the measurement, it's not asking for a value. We know this angle is 60, and we know this bottom one right here is 60, but we want to know what is x. So let's go ahead and solve this. Since it's being cut in half, we know a few things. We know that the angles are equal. We can go ahead and say that angle MAT is going to equal to the angle TAH. So I'm saying that these two angles are the same. And because they are the same, I can make them, the numbers, the measurement of 60 is going to equal to the 4x plus 20 because they are the same. So there's my algebraic expression. Now all we have to do is just solve for x. So we're going to go ahead and draw a nice straight line down. We're going to go ahead and solve for this. So the first thing we want to do is we want to subtract 20 on both sides. Okay, that would be our first step. This is going to cancel. And now we have 4x equal to 60. No, I'm sorry, 60 minus 20 is 40. And then the last step is to divide by 4 on both ends. Okay, that's going to cancel, and so our answer is going to be x is going to equal to 10. Alright, seems pretty simple. Bisecting, cut in half, both of them are equal. There's our equation, and we solve for x. X is 10. Alright, let's go ahead and look at this one. We are given that angles LOV is, again, this means congruent to VOE, so they're congruent. So that tells me that LOV, this angle right here, and I'm going to use this another color here, this angle equals angle VOE, that's this angle right here. So that means they're equal. So therefore, VO, this ray right here in the middle, that's being bisected, being cut in half for this angle LOV. So the measurement of LOV is 7x minus 14, and then we're also going to have the measurement of VOT. We're going to call that, well, that's going to be equal to 3x, we'll add this 3x minus 14, 3x plus 17. So we're going to add that. So we know these two measurements. Okay, so we are given the following. LOV is 7x minus 14, and VOE is 3x plus 17. So now we're going to go ahead and find x. So we're going to go ahead and find x. And we're also going to do the following. We're going to also find, I want to also find the angle of the measurement of angle LOV. So we'll also find this. So we're going to find x, and we're also going to find this measurement. So let's start by finding x. So we know that those angles are the same, so that means that we can say that angle LOV is equal to angle VOE. We know that because it tells us in the given. And we can go ahead and substitute 7x minus 14, and it was given to us that 3x is for the VOE, so 3x plus 17. Alright, so now we go ahead and solve for x. Again, when we want to decide, do we subtract the 7x or the 3x, always choose the smallest of the two, so that would be the 3x. So we want to subtract 3x on both sides. Okay, 3x cancels, and I'm left with 4x minus 14 is going to equal to 17. Next step is to get rid of the 14, so that we want to add 14. Okay, these are going to cancel, so 4x is going to equal to, well, let's see, that's a 7, 1, here 1, that's going to be 31. So let me go ahead and write over here. So we have 4x equals 31, and then we're going to divide this by, let's see if I'm doing this correct here, divide this by 4. Okay, so these are going to cancel, so x is equal to 31 divided by 4, and so I'm going to need a calculator here. Okay, so let me go ahead and pause this video and bring out a calculator for us. Okay, so I went ahead and put the calculator out. 31 divided by 4 is going to give us 7.75, so we're just going to write x equals 7.75. And then we want to go ahead and solve for the angle LOV, so the measurement of angle LOV is going to equal to, well, LOV is 7 times x, or 7 times 7.75, and we're going to subtract 14 from there. Okay, so the measurement of angle LOV is going to equal to, we just need a calculator, so it'd be 7.75 times 7 minus 14. So that'll be 40.25. Okay, so there's our answer. Okay, alright, let's go on to the last problem. Angle addition postulate, similar to the segment addition postulate. If you add this part AOB and you add this part, the one in blue, BOC, together it's going to equal to the sum of the larger angle AOC. So it's really the sum of the parts. So we're going to use this angle addition postulate to put everything, little pieces together, to equal to a large angle. So angle RQ2 is 155. That's the large angle. So this whole angle from here to here is 155. Okay, and we are given 4x minus 20 and 3x 14 for the smaller angle. So we're going to make that the equation. So we're going to say that angle RQT equals to the sum of the smaller angles, which is RQS plus TQS. We go ahead and substitute the values. This is going to equal to 155. This is going to equal to 4x minus 20. And this is going to equal to 3x plus 14. Now we want to combine terms. So let's start with the x's. We're going to combine the 3x and the 4x. So that's going to be 155 equals 7x. And then we want to combine the terms of negative 20 and 14. So that'll give us a negative 6. And now we're going to go ahead and solve for this. I'm going to add 6 on both sides. 6 cancel. This is going to be 161 equals to 7x. I want to divide both sides by 7. Oops, here, 7 here. And so that means that x is going to equal to 23 once you plug it in the calculator. Alright, we want to do the same thing here now. It's asking us to find the measurement of angle RQS. So here's RQS. So this is going to be 4 times 23 minus 20. And let's go ahead and get the calculator out. So we're going to go ahead and do 4 times 23. And subtract the 20 after that. So that means it's going to be 72 degrees on the calculator. So we're going to go ahead and say that the measurement of angle RQS is 72 degrees. And the measurement of SQT or TQS is going to be 3 times 23 plus 14. So let's get a calculator out one more time. So 3 times 23 plus 14 is 83. So the measurement of TQS is, what was that again? 83. Alright, so there's our answer. So there's what they wanted.